Hello there, it's Dr. P. If you have a circuit design that requires multiple analog devices connected to ADC pins on the ATmega 328P, then you will need to be able to change the input channel in the ADMUX register. When the microcontroller is operating with the Auto Trigger Enable bit, ADATE, set in ADC SRA, changes to ADMUX can cause trigger timing to be indeterministic. This means that your code may have bizarre and unpredictable results. For example, in this circuit, my code is written so that the potentiometer on the left, connected to pin A0, should modify the brightness of the LED on the left, connected to pin OC0A. And the potentiometer on the right, connected to pin A1, should modify the brightness of the LED on the right, connected to pin OC0B. The functionality uses timer counter 0 in fast pulse width modulation mode. The timer counter counts to max, and both output compare pins are activated so that their duty cycles can be modified by setting the appropriate output compare register. In this particular iteration of the code, the analog to digital converter is configured to operate with a prescaler of 128 in free running mode with auto triggering enabled. I have the ADC interrupts enabled and the start conversion bit selected. ADC SRA is equal to 0x EF. ADC SRB is equal to 0x00. The reference voltage is AVCC, and ADLAR is set so that I can easily use the ADC in 8-bit mode. I've initially selected channel 0, so ADMUX is initially 0x60. When the ADC interrupt service routine is invoked, the code determines whether or not ADMUX has a 0 or a 1 in the bit 0 location by using conditional control flow. If ADMUX is set to select from pin A1, it sets OCR0B equal to the value stored in ADCH. Otherwise, it sets OCR0A equal to the value stored in ADCH. After the conditional control flow is complete, I used a bitwise XOR operation with 0x01 to toggle the least significant bit of ADMUX. This means that if the current channel is A0, it will become A1, and vice versa. In reality, when I run the code, here is what happens. Dialing the left potentiometer changes the right LED, and dialing the right potentiometer changes the left LED. This is not what I wanted my code to do. This would become even more confusing if I were to have more than 2 analog inputs connected to this circuit. While the potentiometers don't select at random, the issue is that they are not acting the way that they should based on how I wrote my code. This is not a good scenario to be in, particularly if I need to do any type of extensive troubleshooting on this circuit. To solve this problem, we can disable auto triggering. This means the ADC will no longer be operating in free running mode. Once a conversion is complete, we have to tell it when to start a new one. However, this is not a big deal and only takes one line of code to do. The only change I make to my code was to clear ADATE, so my new value for ADC SRA is 0xCF. Then, at the end of my ADC interrupt service routine, after toggling the LSB of ADMUX, I use a bitwise OR operation to set ADSC, the start conversion bit. This tells the ADC to trigger a new conversion cycle. Now the circuit operates exactly as intended. I uploaded the code, and now the left potentiometer changes the brightness of the left LED, and the right potentiometer changes the brightness of the right LED. According to the datasheet, using single conversion mode is essentially the only way to make your ADMUX input channel selection act correctly.